Hello, welcome to another lesson on differentiation from the first principles. SSSCE November 2005 question 4. Find from the first principles the derivative of f of x which is equal to 2x plus 3 all squared. Okay, so let's go ahead and solve our question. We have f of x to be equal to 2x plus 3 all squared. So before that, what we are going to do, we are going to solve this. It is better that when you are using the first principle, you solve the question in the normal way, so that when you know your answer, then it will guide you to know that from the first principle I have to get the same answer. Alright, so if you are solving this question, so if f of x is equal to this, then y is equal to 2x plus 3. Okay, 2x plus 3 all squared. We can also say y is equal to 2x plus 3 all squared. Then what we have to do before we differentiate is to expand. Okay, so 2x will multiply, or 2x squared will give us what? 4x squared when we expand this. Alright, and then 2x will multiply 3 to give us what? 6x times 2 to give us 12x. Okay, then 3 squared will give us what? 9. So when you expand this binomial, or this binomial square will give us 4x plus 12x plus 9. It means that our dy on the x on this will give us what? 2 times 4 will give us 8x. Then you subtract 1 from here. 2 minus 1 will give us 1. So that is 8x plus 12. Okay. So as we have already learned, and this will give us 0. Now when you have a constant number multiplying a variable, okay, and the exponent is 1, then the differentiating becomes the constant, because here is 1. 1 minus 1 will give us 0. And then x exponent 0 will also be 1. Alright. So it means that after solving this particular question, the answer we should get is 8x plus 12. 8x plus 12. So let's take note that we are going to get 8x plus 12. So let's put our answer somewhere here. Okay. So as we are using the first principle, our aim is to get 8x plus 12. Alright. So before that, let's try and expand this. Okay, so that when we are using the first principle, with our substitution of the s plus h and then whatever we are going to substitute to become easy for us. So when you get this and we are using the first, make sure you expand. Okay, so let's expand before. So when you are expanding this, we take the term here 2x and then we square it. That will give us 4x squared as we did here. Then 2x times 3 will give us 6x times 2. That will be 12x. Then 3 squared will give us 9. Alright, so our f of x is 4x squared plus 12x plus 9. Okay. Then we now quote our formula. Our dy on the x, okay, is equal to the limit as h approaches 0, f of s plus h minus f of x all divided by h. Okay, so our f of x is 4x squared plus 12x plus 9, which is the same as 2x plus 3 all squared. Then now, that is our f of x. So what we need is what? The fx plus the h. Okay, so we can work that one somewhere. After that, we come and put it into the formula and then we work. Okay, so you can find your f of x plus h. It means that in the function fs squared plus 12s plus 9, wherever you see x, you substitute s plus what? S plus h. So we are working with the s plus h. So we have what? 4 into brackets s plus h all squared plus 12 into bracket s plus h plus what? Plus 9. So this is what we have. Wherever you see x in the function, substitute s plus h. Alright. Okay, so we have an expansion here to do. So let's do the expansion. So we have 4. Let's work with the square. After that, we multiply by the 4. So s squared will give us s squared. Then s times h times 2 give us what? Plus 2sh. Then we have h squared. You square the h. Then you close your bracket. Plus 12 times x will give us what? 12x. Then 12 times h will give us 12h. Okay, plus 9. Okay, so we have to also expand this. Okay, multiplying 4 by whatever is in the bracket here. So let's continue from here. So our s of h will be equal to what? 4s squared plus 8sh, that is 4 times 2, plus 4h squared, all right, plus 12x plus 12h plus 9. Okay, so this is what we have. When you see the terms here, let's see if you can add any of the terms. So s squared, it doesn't have any common term. sh2, no common term. 4a squared to 12s, 12h. Okay, so we don't have any like term. So now let's come back to our main formula and then we do our substitution. So our main formula, we have what? The limit as h approaches 0, all right, f of s plus h, that is the 4s squared plus 8sh plus 4h squared plus 12x plus 12h plus 9 minus f of s. What is the f of s? That is, so make sure you put it in the bracket, 4s squared plus 12s plus 9. Then you close your bracket, all divided by h. So this is what you are going to have. Okay, so let's continue. So as I said, make sure that when you are subtracting, because the terms here is more than a term, more than one term, so we put it in a bracket so that when you expand, because the negatives are going to affect the term. So let's try and then see what we are going to get. So we are going to have the limit as h approaches 0 once again. Four s squared plus 8sh plus 4h squared plus 12s plus 12 what? h plus 9 minus 4s squared minus 12x minus 9. Okay, all over our h. So you wrote it again because we have to what? Open the brackets here. So 4s squared here minus 4s squared will go, and then 12x, there is a 12x here, minus 12x, 9 minus 9. Okay, so our terms have reduced, so we can have what? The limit as h approaches 0 as what? 8sh, all right, plus 4h squared plus 12h. I think that is 1, 2, 3, yes, all divided by h. So this is what we have now. All right, but here as h is approaching 0, don't quickly put the h here. If you do that, the denominator will be 0 and it will make the whole function here to be undefined. Okay, so what you have to do here, it means that 8sh is over h, 4h squared is also over h, and then 12h is also over h. So every term at the denominator is divided by h. So we can write it as what? Our limit as h approaching 0 as 8sh over h plus 4h squared over h plus 12h also over h. Okay, so h can cancel h here. H squared over h, okay, it will take 1h from there. Indices, so 2 minus 1 will give me 1, so it will become 4h, and then this h will take off this h. Our limit as h is approaching 0, 8x, okay, plus 4h plus what? Plus 12. So when we cancel out the h, we have what? 8x plus 4h plus 12. This is over number 1, so it will become the same thing. Okay, so let me continue at this side. We are almost there. Okay. So now, where I have gotten to, I can substitute the value of what? The value of h. H is approaching 0. So wherever I see h, I'll put 0 there. So I'll have what? 8s is equal to 8s plus 4 times 0 plus 12. So I can only see h here. So I have to substitute 0 here. So we have 8s, 4 times 0 is 0 plus 12 as our answer. So our answer is 8s plus 12. So you see that when we use the normal differentiation, we have the same answer. That is why I said, yeah, let's write it down so that whatever we do, it will guide us to get our answer. So we have been able to solve this from the first principle. I know this is not difficult, okay? You want to enjoy more on best grade mathematics class, make sure that when you go to our channel, you go through the playlist. All the topics are there for you to learn them, both core mathematics and then elective math. I know I will see you again. Even how to use the calculator too is also on our platform. So go through and then learn more. We'll meet again. Bye bye.